Good morning, everyone. Isn't this a beautiful occasion to be talking about AI and machine learning? I must say it's really beautiful here. I am enjoying being with you and the location. So, Peter, thank you for another opportunity to speak to you. This morning we will talk about optimizing manufacturing plants or manufacturing performance using artificial intelligence and machine learning technologies. So for those of you who may have missed my first presentation, my name is Cobus van Heerden. I am from GE Vernova and I am the analytics product manager in our Proficy software and services business in GE Vernova. And I specifically look after our machine learning and analytics software. It's a passion of mine. I've been doing it for many, many years. And it's really a passion for me to help manufacturing and industrial customers improve their performance using these technologies. So I think let's start with why is it necessary? Why? Why do we even talk about it? I think it's always important to ask ourselves, why are we doing what we are doing? Because maybe I would rather want to join the Com-Forth band. I was so impressed last night. I was nearly getting up and dancing because, gee whiz, I didn't realize that these ladies and gentlemen could do many other things than industrial software. Who knows what else they are capable of? But so it was wonderful. So I think it's always important to ask why. So why do we want to optimize manufacturing plants? Why is it even necessary? So if you think about the traditional levels of automation, right? You can have, maybe you have whether you are an industrial enterprise who produces energy, or whether you are a manufacturing company that makes things. Manufacturers makes things, and you can just have a factory with a few machines and completely manual. You can do that. Or you can start to say, okay, how do I digitize? How do I automate my factory? And then you may, maybe deploy a SCADA system to control your machines and to give visibility to your operators. But it's, how do you decide what are the best control settings for your machines? In the end, you want to make your product and you want to make it as efficiently as possible at the lowest possible cost. You want to make it at a good quality so your customer is happy. And if you look at the economics of your plant, of your factory, you obviously want to make just enough of product that you can sell at good enough quality at the lowest possible cost. Right? So you want to optimize, maximize your economics in your factory. And, unfortunately, that is difficult because of something called variation or variability. Variability means I'm trying to make a product of a specific quality, but unfortunately, after a year of production, I see that my quality varies. Some days I make better quality, other days I make poorer quality. Some days I use a lot of energy, other days I use less energy. Some days I use a lot of raw material, on other days less. Some days I have a lot of waste that I have to rework. Sometimes maybe the moisture, the ambient temperatures is very high. It's in the summer and the winter is really cold and it influences my manufacturing process. Maybe some days my operators are really happy because they listened to the Com-Forth band the previous night and they are making good decisions in the plant. They are choosing good settings and the production runs well. Other days, they did not listen to the Com-Forth band, and they're really upset, and they break my machines. So you have variability. Sometimes you have good performance in the process, and other times not. That is what I refer to as process variability or performance variability, and that is an enemy of consistently optimal and good financial performance of your factory, right? Where does that come from? Variability can come from raw materials. So you may be buying raw materials to make your product. You get it from different suppliers, and maybe one batch has one quality, another batch has other different quality. So because the raw materials, the quality of your raw materials vary, you create a lot of variation all the way through to your quality of your final product. Or, like I said, it can come from human behavior, right? Manual decisions that your operators and your people make. And these are not always consistently the best decisions for maximum performance in your factory. Or it can come from ambient conditions like winter, summer, temperatures, moisture. It can come from the fact that your machines may age, your equipment may age over time. Or your process may change over time, your manufacturing process. So variability can come from many places. But in the end, it is an enemy of optimal performance, and it will, reduce your productivity, your efficiency, and it may even break your equipment over time. So that is why optimization means that in your factory, there is maybe up to 30, maybe even 40% efficiency hidden that you can squeeze out, or quality, or even throughput, additional production capacity that you can squeeze out if you are able to run your manufacturing process consistently on the best settings. And how do we get there? Well, we have to lay the foundations of automation, right? You have to start to have a SCADA system to control your machines in a more automated way. You need to start to collect all your data. Maybe I talk about the value chain. So think about the value chain in your factory is you get raw materials, you process the raw materials into a final product that has a certain quality. So you want to get data from your raw materials, collect data from your raw materials. While you are processing your raw materials, while you are running your manufacturing process, you want to collect all the sensor data from all the sensors, all the machines, typically into a process historian. You want to apply maybe a manufacturing execution system, an MES system, so you can guide your operators to operate the plant in a consistent way based on standard operating procedures, and you want to collect all that production data. Which order am I running at the moment? On which machine? What are the raw materials, the recipe that I'm using? All of that data you want to collect. And then finally you have a product and you want to record all the quality data. Okay, you want to record, we spoke about sustainability the first day, all the sustainability data. How much water am I using? How much electricity am I using? How much steam or fuel? And then quality, right? What was the final quality that I produced? So if you have all that data recorded, you can now start to optimize. You can start to apply machine learning and artificial intelligence to understand what are the relationships between good and bad quality with the settings on my process, with the raw material settings, and how can I reduce variation in quality, in yield, in throughput, in recovery, in energy usage. So how can I reduce variation? Firstly, understand the variation. I have reduced the variation and then push the process to optimal performance. So let me ask a question. I won't ask the audience to dance. I mean, we are all sitting here, so let me at least get you a little bit involved. let's ask a question. So who can tell me on average, if we take the average of all manufacturing plants out there, what is the average efficiency of a manufacturing plant in industry? You typically measure that in a metric called OEE, overall equipment effectiveness. So typically 100% OEE means that when you are scheduled to produce something, you are producing precisely the right amount. All of it is 100% good quality, and you never have downtime. So you are running the whole time. And so if it's 100% the right amount, 100% quality, and 100% availability, that is 100% OEE, or referred to as 100% efficiency or effectiveness. So what would you say is the average in industry? Somebody tell me. Wow, that is spot. Yeah, it's a good. It is 65 roughly. What is world class? 85. Peter, at least you know that, right? You should, after many, many years, know that one by now. 85. Now just think about 65. The difference between 100 and 65 is 35% efficiency. 35% efficiency that's there to be unlocked. You don't have to build a new plant. You just need to unlock that 35. It's like the quest for 100, the quest for perfection, okay? How do you get there? Well, by doing the foundations right, by automating, by digitizing, by collecting all the data, and then start to layer optimization on top. Okay, so I'm not talking about the foundations today. Peter and the team can tell you all about that, and I think we've been talking a lot about that in this conference. I'm talking about how do we squeeze out that 35%? Now, if you think about the value of 10%, if I'm a manufacturing enterprise and I can improve 10 plants' productivity by 10% each, what have I done? I have just magically unlocked one whole new manufacturing plant that I do not have to build. It's just there. It was hidden capacity in my... And that is the power of optimization. Now, we're all talking about AI and ML. These technologies have now matured so that proven software is available that you can layer on top of your operational systems to do that. Whether you are a solution provider or a manufacturer yourself, or even whether you are producing energy, you can use analytics to increase, to maximize your performance of your operations. And that's what we will be talking about next. But that is why this is valuable, why this is important. Okay, so the second reason why it is important is that processes are becoming more complex. Whether fortunately or unfortunately, that is just true. Maybe a generation ago, there was one or two machines and you needed to make one or two decisions based on one or two measurements. Today, it is very complex manufacturing processes with so much data and it is nearly impossible for a human to always make consistently the best decision. And also, the environment is becoming more dynamic. What does that mean? More often I need to switch to different raw material suppliers. I need to make more products because my customers want customization. I make more products in the same plant, on the same line, so I have to switch between. So it's difficult what is the precise best recipe to get the right quality. So it's just becoming more dynamic and more complex. And for that reason, optimization software is not a luxury anymore. It's a necessity now. Just like you have a SCADA to control your plant, you have a MES to execute production consistently, but these systems do not optimize. They do not tell you how to precisely choose the best settings to have the best. for that reason, optimization is becoming more essential. Okay, so those are the reasons why it's important. Now, what is CSense? So in Vernova, in the Proficy software and services business, our portfolio of software is called Proficy. And essentially we have SCADA software, we have a historian to collect all the data, we have an industry-leading MES system, but we also have analytics and optimization software, and that software is called CSense, Proficy CSense. So what is it then? It is industrial analytics software that improve manufacturing plant performance by easily implementing on top of whatever OT systems you may have. So it works very well with our own Proficy, SCADA, historian, and MES systems, but it can work with any, on top of any historian, SCADA, MES systems. So you can layer it on top, because typically in a manufacturing plant, you know, if you have an enterprise of 100 plants or an enterprise of 50 plants, often these enterprises grow by acquisition. You may buy some plants here and there, and more often than not, you may have different SCADAs, different MES systems, different, and so, you know, it's also, I've been talking to some people here at the conference, and they told me how important it is for them to separate optimization from core control. So for example, your PLCs, your control systems, they run your plants. So typically best practice is to not try to do optimization in there, but you leave your core reliable controls in that layer, your SCADA, PLC layer. And then on top of it, you know the typical layer 1, 2, 3, 4 automation software layers, but you can layer optimization, for example, using CSense on top of any mixture on any plant of automation systems that you have. To improve performance, performance can be anything that matters to you, right? Is it throughput? What is most important to you, to your plant? Is it throughput? Is it yield? Is it waste? Is it quality? Is it energy? To improve that performance by up to 10% or more rapidly. What is rapidly? Well, rapidly is typically within 1 year, but often within 6 months. And what we find is that when customers use our software, then often within hours, they gain new insights from their data through analysis that is super valuable. Like they may learn, oh, if I use this combination of settings, then it's better for my evaporator to start up faster. So let's just go and implement that. And 1 hour later, their evaporator runs better. So there can be quick insights too that is really valuable. How does it do that? Well, it does that by helping you use the data that you have to learn what are the best settings to run your plant on to get best performance. And, you know, it uses AI and machine learning and optimization techniques to do that. And you can deploy it on premise or, you know, in cloud environment. So that in short is CSense. Now, CSense is unique in the sense that it is quite comprehensive. It offers 5 capabilities in a single solution from a trusted global vendor like GE Vernova, tightly integrated with a Proficy portfolio of products. And those are that with the same solution, you can analyze your data. So it has analysis tools, typically for process engineers. So your engineers, the people in your plant that are responsible for improving and optimizing production, they have easy machine learning tools in CSense to combine your data from various systems and being able to analyze it. And the reason why is that they can very quickly answer questions like, why was the quality bad yesterday? Why did we have downtime on this machine? All the why questions they can answer quickly from your available data. Secondly, monitoring. Monitoring, if you think about a manufacturing plant, you have your equipment, you may have controls on top. Often there are many PID control loops. You may have a whole process line. You may have a whole unit operation, whether it's an evaporator or a pump. You can monitor these pieces of equipment or these PID loops or even the sensors that, whether they are healthy. Now, typically in SCADA systems, basic monitoring would mean that you put a single threshold on a single tag and you get an alert when it goes out of specification. With CSense, you can use more advanced techniques that look at all the sensors together and earlier detect problems. So it saves you time. Earlier, you have more time to even avoid a problem, avoid a breakdown, so through more advanced techniques of monitoring, essentially you can earlier detect problems. Then prediction and forecasting. It has machine learning and AI techniques built into the product, so essentially you can leverage that to predict things ahead of time. For example, many times in manufacturing plants, you measure quality with laboratory samples. You would take some samples, send it to a laboratory, and then maybe 8 hours later, 4 hours later, you get back your results. But then you may have been producing product for 4 or 8 hours, and it may have been bad quality product. So it's too late, and it's not continuous. Now, I know today you get vision systems, you get more and more real-time quality measurements, so I think that is becoming less of a problem. But in that example, you can use a machine learning model to continuously predict the quality so that you can do continuous quality control. Or another example may be that you are a wastewater or a water processing facility and you want to forecast over the next 24 hours, how much water will I receive? Will my plant have to process? Well, you can use machine learning to, based on weather patterns and other forecasts, what will be the inflow into the plant hourly over the next 24 hours. So using machine learning techniques embedded in CSense, you can do prediction, forecasting, anomaly detection, all the types of things that you can do with machine learning and AI algorithms. Then simulation. Your engineers or the people who understand your manufacturing plant and processes or machines, they can embed their knowledge into digital twin models. So they can create mathematical models either based on data that you have with machine learning or based on their understanding of your machines. And those models can then be used to simulate or to do what-if analysis. For example, it is much faster and cheaper and often safer to test certain scenarios against the model than test it on the real plant. Because on the plant it may be slow, it may be expensive, and it may even be dangerous. So, process digital twin models can be created in CSense and then used for offline analysis simulations. Lastly, optimization. Optimization means that you can deploy optimizers, analytics that really work out, either recommend or even in closed loop control the process by calculating what are the best control settings at any moment in time to now run the machine on the plant on. And that can be done when it is safe and feasible. It can be done with closed loop control. Or it can just recommend it to your operator and the operator can use the recommended settings. So just for sort of decision support. So all of those capabilities in a single solution is what makes CSense unique. Okay, so essentially what did we say? Well, we said that, the analytics can help you use your data to quickly understand through analysis the variation in performance. Why do I have variation? Then you can configure and deploy analytics to reduce that variation, to run more consistently at optimal settings. But then also you can deploy optimizers, to really push the process to the maximum, to unlock that additional 10, 20, 30% of efficiency in the plant. So that is really how, and you can layer these analytics on top of your existing OT infrastructure. So for example, you don't have to go and make changes to your SCADA or changes to your PLC. It's independent because normally these systems are meant to control the plant. You don't want to touch them. You don't want to interfere with them. They are highly regulated. Now, this is an optimization layer on top that really just fine-tunes settings within safe boundaries to squeeze out that additional productivity. So in this way, CSense really accelerates continuous improvement. So it enables your engineers to work together, to collaborate. So more often now I see that in manufacturing enterprises that people are creating centers of excellence. They take all the engineers that have the knowledge, and maybe if you are fortunate, if it is big plants, then every plant will have its own process engineer or Six Sigma black belts, continuous improvement engineers. But often also when they're smaller plants, these people sit centrally, maybe they sit at the headquarters, and they are optimizing remotely. They are working together to optimize multiple plants. So this enables you, it provides a solution that enables and empowers your engineers to work together, whether it's remotely or many plants, but to essentially connect to the different data sources you have, to explore and visualize and model the data using the analysis tools. Why? To answer questions, to gain new insights, to find out quickly how can we improve the process. Time to insight, to rapidly help them discover, and then it is great to gain new insight, but if you can't deploy that insight, if your engineers have to go to IT for every little thing that they want to do, they say, hey, I want to recommend this set point to the operator, so you need to go and change the PLC code. Oh my goodness, it's going to take a year. I need to get 20 approvals. And no, this is an innovation layer where engineers can layer innovation and improvements on top of the OT layer within safe boundaries, obviously within the limits and the rights they have, in the form of analytic solutions that can then create value. And they can, basically iterate through continuous improvement projects faster in this way. Also, if you look at analytics, traditionally there are barriers to actually getting value from analytics. And, we make a big effort to design CSense to remove those barriers. So what are the barriers? Well, firstly, the barriers that often the data is in many different places. Your quality data is in one database, your historian has other data, your MES system, your raw material database. So firstly, how can I access this data? So CSense makes it easy for engineers to access this data. Secondly, to combine the data together, to prepare that data, to clean it, to format it, to maybe filter bad data out, because every question you want to answer often requires a different data set. You don't need all your data to answer every question. And in this way, for every question, every analysis project, the engineers can easily access the data they need and prepare a specific data set that will help them answer that specific question and save it for reuse. Prepare that data set. Then the second barrier is, now that I have the data, it's so much data. Where do I look? What can I learn from it? So CSense make the analysis of these data really easy for engineers to rapidly discover new things, to, in a few clicks, train machine learning models or AI models where you do not have to be able to program in Python or understand AI ML. A process engineer can click a button and have a model from which they can learn something really quickly. But then what does it help if you cannot deploy that insight? So last barrier is that it provides a secure industrial way to deploy these analytics and to layer them, so that you can, continuously improve and increase the productivity and efficiency of your manufacturing plants. So what do you get when you buy CSense? Well, CSense mainly consists out of 3 components. There are analysis tools for engineers called troubleshooters. And it is, Windows-based application you install on your desktop or on any Windows computer. And it has analysis tools called troubleshooters with which engineers can easily connect to the various different data sources, whether it's data in a text file or data in a SQL database, data in Proficy historian, data in MES system, and load these different data sets, combine them, clean them, learn from them. So troubleshooters are the first component. Secondly, there's this visual drag and drop analytics development environment called the architect. And this is really where your different types of engineers, your control engineers, maybe your automation engineers, even your reliability engineers, maintenance engineers, or your data scientists. Maybe you have data scientists where they can collaborate to create analytics that can then be deployed to the CSense runtime into production to continuously analyze or monitor or predict or simulate or optimize the process. As they do these continuous improvement processes, they can deploy. Let's say they've done a process. Hey, I give you an example. We have a customer that they wanted to reduce the startup time of their evaporator. So they loaded all their data. Their engineers combined data from across the plant that relates to the evaporator. And with CSense, quickly they found out, well, if we use these startup settings, we think we can reduce the startup time. Well, in that case, you want to be able to deploy that insight, right? Analytic that will say, hey, we're running this product now on the evaporator, so use these startups. These are the optimal startup settings. Write it to the MES or the SCADA. And then in that way, they reduce startup time by 20%. 20%. So that is essentially, analysis tools. And you can layer these. Maybe that's one example of a continuous. And after that, they've done with the evaporator. They look at what are the next most important thing we can improve. Maybe let's go on to the next, and you can repeat continuous improvement projects and so continuously improve efficiency in this way. CSense is a proven solution that is being used globally across all industries. You will see little stories here, just snippets. I know you probably can't read here, but you will see a food company reduces waste by 75% and customer quality complaints by 35% by using CSense to analyze their data. So you see examples of customers in food and water, energy, paper, building materials, metals. Automotive company monitors the health of production line equipment on an enterprise scale. Mining, food and beverage, brewing company, press wood products manufacturing, improve line quality and speed. So it's really, these capabilities are not industry specific. I mean, it's generic capability that are being used globally across the world by customers in various industries to use all these capabilities to continuously improve their production, and often improvements by 10% or more. And if you want to see more detailed success stories, then on our website there are detailed stories of some of these use cases. But tell me, time, I don't have an idea. Oh, okay, thank you. So, very exciting news this year that I'm really happy to share with you is that we are taking one big step this year in that in our Proficy software portfolio, I already mentioned to you that we sell SCADA solutions, and we sell many of those, right? So often when a customer just starts their automation journey, they need a SCADA. And people may ask me, so, hey, you know, when am I ready to use analytics? Do I have to have all SCADA, Historian, MES? I have to basically do everything, and then at the end I can only optimize. Or when can I start with analytics? Well, the answer is you can get some value wherever you are in your journey. You may not be able to get all the value, but you can get some value wherever you are in your journey of automation and digitization. So this here, we sell SCADA systems, we sell historians, many of them, we sell MES solutions, many of them. So we have decided that we're going to enable, excuse me, I'm getting too excited here. This is really exciting, so Thomas, next time you must catch it. So we've decided that we are going to release a starter runtime, so a free version of the CSense runtime, so a small analytics runtime, and we're going to make it available with all our SCADAs. So whenever you buy a GE SCADA, whether it's iFix or Simplicity, or if you already have a GE SCADA, if you upgrade to the latest version, it has to be the latest version, 2024, you will get for free a CSense SCADA starter runtime. What does that mean? It means it will enable our SCADA customers, which are only starting maybe on their automation journey, to participate and get some value from AI and machine learning. Because what does a SCADA do? It controls, it's connected to your PLCs that are full of PID loops and control logic. It produces alarms. You can apply already analysis and these techniques to that kind of data. So I'm happy to introduce to you that from this year, each GE SCADA that you buy or you upgrade to the latest will be entitled to one free version of what we call CSense SCADA Starter Runtime, as well as one Operations Hub Ultimate license, so that together with these, with your SCADA, you get a small analytics runtime and the ability to visualize the outputs that analytic runtime produces, also maybe in a web UI to some people that are not necessarily dependent on your SCADA solution. But that is a limited license. So essentially it is a one-tag CSense runtime. What does it mean? You are limited to and allowed to deploy with it one CSense analytic that writes out or predicts or controls one output tag. So whether it's one alert you are writing out back to the SCADA, or whether it's one prediction you are making, or whether it's one set point you are optimizing, one output. But then we don't give you a blank sheet of paper. We have some templates. Templates for alarm pattern monitoring, sensor health monitoring, PID control loop health monitoring, one machine learning template, a model template to train a machine learning model and deploy it, and also one model predictive control template. These templates will be available for download from our support website. So typically, if you are a G customer, you know there's a website where you can go to typically download SIMs or patches, or you will be able to download the templates from there for this runtime. So alarm pattern recognition, your SCADA produces alarms. But what we're hearing from our customers is, hey, you know, maybe there's a burst of alarms. Or if I have a long alarm history, can I learn something from the sequence of events in which alarms typically occur? Or the root cause, you know. When this alarm happens, then it's always followed by this alarm. When alarm A happens, it's always followed by alarm B, typically 30 seconds or a minute later, and this happens all the time. Or when there's a certain burst of alarms, you get a certain pattern of 3 alarms that always repeats, always follows one another. That is the sort of things, insights that this template will allow you to unlock. Sensor health. So typically, SCADAs monitor sensors, connected to sensors, and sensors can stop working. Sometimes they produce bad quality data, or they go out of limits or calibration. And there's a simple template to monitor the health of sensors. Is it producing bad quality data? Is it just flatlining or not changing anymore? Is it outside normal limits? PID control loops. SCADAs are connected often to PLCs, which normally have many often PID control loops that control your equipment. If these loops are not working well, and they typically over time degrade in performance. Why? Because the process change or the machine ages. You need to retune them. Maybe the sensor is not working well, or the actuator, the pump, the valve, whatever it is controlling is not working well. Maybe the loop needs new or better PID settings. If these loops are not working, they create a lot of variation. That variation will break your equipment over time and will result in bad quality production over time. Now, with this runtime, CSense out of the box allows you to monitor and tune all your PID loops. With a free runtime, you are allowed to monitor 1 loop, just to get to know, do a POC, get to see how it works. If you upgrade to full CSense and you buy a CSense runtime, you can do tuning also of the loops and monitor all your PID loops. AI ML model template. I mentioned to you that CSense has out-of-the-box machine learning models. It also has Python embedded, so full Python inside. So we know that Python is the machine learning and AI language of the industry. Not all customers have data scientists or people that can program in Python. But you don't have to with CSense, because if you are an engineer and you also want to utilize ML, well, CSense has one-click out-of-the-box machine learning models that are useful for most use cases. But if you do have data scientists and people that say, no, I want to do my own thing in Python. I know exactly what I want to do. It's a custom algorithm. It's deep learning, and I want to use specific tools. Well, you can do that, because CSense also supports what we call the Open Neural Network Exchange, which is a machine learning standard from Microsoft, which means most AI model development tools out there can export their models in a format called ONNX. You save it as a file. Then in CSense, there is an ONNX block. You can literally just import that model, map it, and deploy it in a secure industrial way. So you can also sort of bring your own models and deploy it via ONNX, or if you have data scientists that love Python, CSense have full Python inside, and they can create a Python algorithm and just implement and deploy it there. But for the free runtime, we have just applied a simple point-and-click neural network model that you can train on your data and deploy, and as long as it predicts one output, then you can deploy it for free with a free starter runtime. Model predictive control. Test. Are you still awake? Just testing. So who can tell me what is the most popular control algorithm in industry? Trick question. What is the most popular control algorithm in industry? Come on, Peter, is this an industrial software conference? SPC. At least somebody is trying. I'm really impressed. But it's wrong answer. Okay, now the answer is PID. PID, proportional integral derivative. It is the algorithm that's controlling 99%, 95% of all control loops in the world. Probably it's in every PLC. You know, we have Moxie, we have Back-Off, we have many industrial computer suppliers. If you ask them what's inside, then often PID control loops. That's what's controlling most of the... Now, the thing with PID is one input, one output. It's a linear control technique, and it's not suitable for some use cases, right? So typically when you have multiple things that interact with one another or you have long process delays, PID is not necessarily the most suitable. So if you want to go one step up to more advanced control, then the most popular advanced control technique in industry is called model predictive control, MPC. Now, CSense has MPC out of the box. It can also do PID, but that's not the point. You have your PLC or SCADA for that. That's your critical control loops. But if you want to optimize and more advanced control, MPC, model predictive control, CSense has a drag and drop out of the box. And with this free runtime, all our SCADAs, GE SCADAs has now access to MPC. And you are allowed to deploy one MPC controller with 2 input, 2 output with this template. So we're providing an MPC template with free runtime. We are not only doing it for our SCADAs, we are also doing it for our historians. Okay, so you may be installing a SCADA, you're only starting your automation journey, but the good news is the next step is let's collect all the data. Well, for that you need a historian. So if you do buy our historian, and the latest version of our historian, we are including not for all historian licenses, but only for term or subscription, cloud historian subscription. We have our historian you can deploy on premise, but we also have a cloud-based historian which you subscribe to. So if you buy a historian term license, let's say a 3-year or 2-year or 5 years, and or if you subscribe to our cloud historian, let's say you have many plants, you want to collect your data into the cloud and then use it there for reporting analysis, then we include a free historian starter runtime with that historian. With that historian starter runtime, we make available again you get one free runtime of CSense, but also a OpsUp Ultimate term license. So again, because it's a term or cloud subscription, if your historian is a 5-year license, you will get the same term CSense license, 5-year license, and the same term OpsUp license, 5-year license, one user, or a historian starter runtime. It's in the same as the SCADA starter runtime. Essentially, it is a one-tag CSense runtime. We also make templates available with that runtime. Some of the same templates than with the SCADA runtime. You can see alarm pattern, sensor, PID loop, AI/ML. But because this is not control, we do not make the model predictive control template available here, and we add some new ones. Because you now have historical data in your historian, we make a tag correlation template available, meaning what are the highest correlating tags in my historian? With that template, you can calculate that. You can select tags from your historian, correlate them with one another, and identify the top correlated tags. Or a time series forecasting template. With that template, like I mentioned, I used the wastewater example. You can take any historian tag. A model will train on the historical data of the tag to pick up the patterns and then forecast, let's say over the next 24 hours, hourly, what is the expected forecasted values of that sort of tag into the future. And so again, with this historian starter runtime, it's a one-tag CSense runtime. You can deploy, you are allowed to or limited to deploy any one CSense analytic writing one tag out to external systems and or one instance of any of these templates Again, the templates will be available for download from our support website. So, correlations template, like I mentioned, CSense, you just drag a block. We provide this template out of the box. You just configure, you pick the tags in your historian you want to correlate, and then write the correlations back to the historian. To basically answer the question, what are the relationships among tags? What are the highest correlated tags? Or the time series forecasting template. I mentioned the example of wastewater plant again. Again, this, you can see there a Python block. What is this? Is this that's the pointer. You can't probably see it, but there you have a Python blocks. So this template is using standard Python modules like pandas and stats models to basically forecast the future of any selected tag. Okay, so that is my story. 9 minutes left. So just recap. What did I tell you? Firstly, optimization is not a luxury anymore. It's becoming more and more essential. We live in the age of AI, artificial intelligence. It's all around us. Everybody is talking about us. Now, I have good news for you. The good news is that all our W.A.G.E.S, SCADA, and historian customers can now start to participate with free runtimes in AI, machine learning, even when you start with a SCADA or when you just have a historian. Obviously, if you have SCADA and historian and MES, and you can bring all the data together, you will get most value. But so who and when can you start with analytics? My answer to that question is wherever you are. If you just have a SCADA, you can get some value. You can monitor and tune PID loops, you can optimize alarm patterns, optimize your alarm logic and stuff. If you have historian also, wow, now you can do more. You have historical data, you can analyze it, you can create correlations, you can train machine learning models. If you also have a MES, wow, now you have all your production data. So you can really optimize what are the best settings when I make a specific product on a specific machine in the first phase of a batch. You can really optimize even better. Well, if you have also your sustainability data, you've seen the sustainability insight solution that we have out of the box for that. So you can really start with machine learning and AI wherever you are in your journey, and we're making it easier than ever. We're making it possible for even our SCADA and historian customers to start with these free runtimes. And is it valuable? Well, if you have a need to improve efficiency from 65 to 100, my question always to any customer is, what would be the value for your plant to improve quality by 10%? What is it? €1? 10,000 euros a year? Well, if it is 10,000 or 1,000 euros a year, let's rather go and listen to the Com-Forth band, because maybe that's not worth making an effort, right? But if your answer to me is €1 million a year or 10 million euros a year, maybe let's focus there and apply analytics and see if we can squeeze, even if it's 5%, and enable your own people, your own engineers to quickly deliver that kind of value year over year over year, to move from 65 to 100 and to deliver millions of additional value to your plant using analytics together with our Proficy software. And if you want to know how to do that, there's no better place to go than to just ask Peter, and he will know exactly how to help you start with that. So thank you. With that, that's all from me. Any questions?
Van-e kérdés esetleg? I think you had a very comprehensive overview about CSense, so it seems that everything is clear for everyone. They know questions.
I may have bored them to death or stunned them to silence. I don't know which one it is, but we will leave it there. Thank you so much for your attention.
Thank you, Cobus.